Hello little scientists! Welcome to Alan IntelliBrain. We all use different types of spherical lenses in our day-to-day life. But do you know how they form images? Let's observe in this video. From the IntelliSmart box, take out the Reflection of Light Activity Kit and the Refraction of Light Activity Kit. Take out the concave and convex lens and the tea light candle from the Refraction of Light Activity Kit. You will also need the mirror or lens stand from the Reflection of Light Activity Kit. For instructions on how to assemble the mirror or lens stand, watch the Image Formation by Concave and Convex Mirrors video. You will also need a white sheet, a matchbox and a black marker or sketch pen from your home. Place the convex lens into the slit of the stand, like this. First, we have to find the focus and center of curvature of the convex lens that we are using. Its focus will come around 10 cm as mentioned on the envelope of the lens, but it may not be exactly 10 cm. To find the focus, first find the center of curvature. For this, place the lit candle at around 20 cm distance from the lens. Now, try to obtain its image on the white sheet. Find that location of the candle where a sharp, inverted and same size image is formed on the other side of the lens. This point will be the center of curvature. Mark this point as C on the table. Similarly, mark C on the other side of lens where the candle was placed. Now, mark point F as focus exactly in the middle of the lens and point C here. Similarly, on this side. To exactly locate F, place the candle on the marked midpoint here and try to obtain its image on the sheet on the other side of the lens. If you see a blurred and magnified image of the candle throughout all positions of the paper sheet, then that point will be the real focus. If your previously marked focus point has changed, then you need to change the earlier marked focus point on the other side of the lens also. As the points F and C are marked, now it's time to observe the image formation of the candle placed at different positions from the lens. So, first of all, let's place the candle beyond C. Here. Try to find its sharp image by moving the paper screen between F and C marked on the other side of the lens. Here. Did you observe this image? Now, place the candle at C, the center of curvature. And let's see where is the image formed. A real and inverted image is formed at the center of curvature on the other side of the lens. Now, let's place the candle between the center of curvature C and the focus F. Here. Let's observe where is the image formed now. A real, inverted and magnified image of the candle flame is formed beyond the center of curvature on the other side of the lens. Now, place the tea light candle between the lens stand and the focus. Can you see a virtual image has been formed which can be seen inside the lens? Now, replace the convex lens with the concave lens. And now, let's try to find the image of the candle. You will not get its image on the sheet now, as a virtual and erect image will be formed. When we place the candle very close to the convex lens, a virtual and magnified image is obtained. And when we increase the distance between the candle and the lens, the size of the image reduces and real images are formed. These real images can be seen on the screen. The image formed by the concave lens is always virtual, erect and smaller in size, whatever is the position of the candle. The image formed by a convex lens is real and inverted. The image formed by a concave lens is virtual and erect. Visualize science with IntelliBrain and fall in love with learning.